Section 2.5, Graphs and Transformations. We are going to be graphing several different types of functions in this section. When we start graphing, it is important that we understand what the graph actually is. So let's read this definition. The graph of a function is the set of all ordered pairs. All ordered pairs. These are points on the graph, such that y equals f of x. So what does that actually mean? Let's take an example. Let's say y equals 5x. We could choose any value for x. Let's say we choose 1. We're writing an ordered pair, x is 1. To find the y that goes with it, we would plug in 1 for x. So then y is 5. When x is 1, y is 5. This is an ordered pair. It's a point that would be on the graph of y equals 5x. So you could do that for infinitely many values of x and get points that are on the graph. That whole entire set of points would make up the graph of the function. So we are going to practice that concept with what's called the point plotting method for graphing. You choose values for x and use the function to find the corresponding values of y. So it's kind of like evaluating a function, which we just did in this unit, where you plug in the number for x and work it out, and then you get an answer, which will be y. So let's go ahead and try some problems. Our first function is f of x equals 2x. Remember, f of x and y are interchangeable, so you may see it in this form. You could also see it as y equals 2x. These mean the same thing. Now, this would be considered a linear function. The exponent on the x is a 1. We don't see it there, but it is a 1, and that's what makes it linear, because it is degree 1. Go ahead and write that there. Anytime you graph a linear function, the shape will be a line. So we kind of already know what shape we're going to get before we even start graphing. Okay, so the point plotting method, you choose values of x. We could really choose any number for x. However, we want it to fit on this coordinate system that we have here, which is really just numbered from -5 to +5. So a good choice usually is to choose x to be -2 all the way through +2. If you're not sure, I would start with those, and then once you start substituting, you may decide, okay, I need some different x values, but that's always a good place to start. So what you do then is just plug those into x in your function. If you need to show the work, sometimes you will, sometimes you won't. But if you needed to, you could just come out to the side of your table, and when x is -2, I'm taking 2 times -2. Again, just like when we were evaluating, we put the number in place of the x. These are multiplied, so we multiply 2 times -2, and the y value, sorry about that, would be -4. If x is -1, we're going to do 2 times -1, which would make that -2. And so if you don't feel like you need to write that out, it's okay here on this simple example to do the multiplication in your head. So 2 times 0 is 0, 2 times 1 is 2, and 2 times 2 is 4. So once you complete your table, these are ordered pairs. We will plot these on our coordinate system. So even though we're not writing it, normally we would write this ordered pair as -2, -4, -1, -2, and so on. I'll go ahead and do it for this problem. You do not have to write them out in this form, but that's what these numbers in the table are representing. We have 5 points that we need to plot on our graph. So here we go, -2, -4. So 2 left and 4 down. Put a point there. -1, -2, 0, 0, which is also known as the origin, 1, 2, and 2, 4. So like we said before, the shape's going to be a line. If you have a straight edge, I would use that to set your straight edge right up against your points and draw your line. Make your line extend beyond the points, because these 2 points at here and here are not end points. The graph keeps going past those. So I do not have a way to make my lines very straight using what I'm using to do this video, so bear with me and we'll try to make it as straight as possible. Again, on your work, if you could use a straight edge, that would be great. Then on the ends of the line, let's put arrows, indicating that this actually keeps going forever. And this graph is representing all the points, all the ordered pairs that make this equation true. Okay, let's try another one. Number 2, g of x equals x minus 2, again is linear because the exponent on the x is a 1, it's degree 1. So I'm going to go ahead and use the same x values, -2 to +2. And this time when we substitute for x, we're putting in that number and subtracting 2 from it. So for -2, it's going to be -2 minus 2. Same signs, add and keep the sign. And then we're plugging in -1 for x, so -1 minus 2. Remember, this is x minus 2 that we're calculating, the right side. So this would be -3. And 0 minus 2 is going to equal -2. 1 minus 2 is -1. And 2 minus 2 is 0. Okay, so let's plot those ordered pairs. -2, -4. And then we have -1, -3. 0, -2. 1, -1, and 2, 0. And when you know you have a linear function, after you plot your points, make sure that it does look like a nice straight line would go between all those points. And then again, take your straight edge, line it up next to your points, extend beyond those last points, and put some arrows on the end. So this is the graph of x minus 2. And again, this method we're using for graphing right here is called point plotting. Okay, number 3. This is called the absolute value function. We see those bars there. We've already learned that those mean absolute value. Absolute value function is what we have here. So the shape of an absolute value function is just something you're going to want to memorize. It is a V shape, okay? V shape. So anytime you're graphing and you have the absolute value bars in there, we just need to know, okay, this graph is going to have a V shape. Let's go ahead and plot points like we did for the others. And again, I'm going to use those same x values. Now what's happening is we're plugging this x value in for x, which is between the absolute value bars. So when I substitute in -2, it's going to look like this. And so I just take absolute value of -2. Remember that absolute value is always positive. I can get back to my previous slide. Okay, sorry, we lost the video for a moment. Let me get back to where we were. Okay, so absolute value is always positive. So we take the absolute value of -2, we get +2. We take the absolute value of -1, we get +1. Absolute value of 0 is 0. Absolute value of 1 is 1. And absolute value of 2 is 2. Okay, let's plot. So -2 on the x, left 2, and +2 on the y's up here. -1, +1, 0, 0, 1, 1, and 2, 2. And so you can see the points are in the arrangement of this V shape. And it actually does have a sharp point. So over here on the right side, I'm going to start at the vertex is what this origin would be, and go up to the right. You could use a straight edge on this graph as well. And then on the other side, straight. Sorry, I'm not getting that very straight. And again, put arrows on the ends of your graph. And that is what the absolute value function looks like. We kind of want to memorize what these basic graphs look like. Number 4 will be the basic graph for the quadratic function. We know that because the degree is 2. It's an x squared. X squared means quadratic. And we talked about the shape of a quadratic function when we were solving quadratic equations. If you remember, that shape is a parabola. Sometimes it opens up, which it will here for this very basic function. It could also open down, and that would happen if you had a negative x squared. So we're going to use the same x values, -2 to +2. And when we substitute, we will put parentheses because we have this square. So parentheses -2 squared, which means -2 times -2 is +4. And then -1 squared. -1 times -1 is +1. 0 squared is 0. 1 squared is +1. And 2 squared is +4. So let's draw that graph. We're going to plot -2, 4. -1, 1. 0, 0. 1, 1. And 2, 4. Now this kind of looks like it could be a V shape as well, but you just have to memorize that, okay, this is a quadratic function, its shape is a parabola. A parabola does not have a sharp point. We say the graph is smooth at the vertex. It curves, it is not sharp. So you don't need a straight edge for this graph. You just want to kind of curve through that vertex. And we still do want to put arrows on the ends of our graph. So that's the graph of x squared. The next function we're going to look at is the square root function. So we'll go ahead and name that up here. This is the square root function. And it also has its own shape. It's going to have a starting point, and then it's going to curve up and to the right. It's gradually going to go further and further up, but not very steep. It's just a gradual slope upwards. Now let's think about our numbers here. Well, normally we start with -2. But if I put -2 in place of x, now I'm going to have square root of -2, which is an imaginary number. And when we plot numbers on this coordinate system, we cannot plot imaginary numbers, only real numbers. So if an x value causes me to get an imaginary answer for y, then I don't want to choose that x value. I want to choose different x values. So I'm not going to choose any negative numbers for x. So we could do 0. We could do 1. Then when I think about 2, well, if I put 2 in there, square root of 2 is a decimal number that I would have to round, and then I would have to estimate where to plot it. So really, I would prefer to have perfect squares. So I'm not going to use 2, I'm not going to use 3, but 4 is a perfect square. And the next perfect square is 9, but I didn't make this grid big enough to go to 9 on the x-axis. So we're actually only going to do these 3, 0, 1, and 4 for the square root function. So when we take the square root of 0, we get 0. The square root of 1 is 1. Remember the radical, we only give the positive square root. And square root of 4 is 2. So let's plot 0, 0, 1, 1, and 4, 2. Okay, now remember, look up here at the shape. So it's going to start here at 0, 0. It's going to curve through these points, gradually going up. So you put just an arrow on the right end, and that is the square root function. Okay, next we have the cubic function. Or you could just say the cube function. The degree is 3, and the shape of the cube function looks something like this. We could go ahead and go back to our normal x values and choose -2 to +2. And let's see what happens when we plug those in. So I'm going to put parentheses around it when I substitute. So -2 cubed means -2 times -2 times -2 is going to give me -8. And then -1 cubed will equal -1. 0 cubed is 0. 1 cubed is 1. And 2 cubed is 8. So I didn't make the grid big enough to plot the first point or the last point, so we'll plot the middle 3 there. So -1, -1, 0, 0, and 1, 1. So you really have to have the shape memorized here to know how to draw it, because it looks like you could just draw a straight line through there. But the shape for x cubed is not a straight line. So you're going to start kind of down low here in your third quadrant and curve through those 3 points, and then put arrows on each end. And that is the graph of x cubed. And so in the notes, I went ahead and printed, or I should say I put in copies of each of those basic function graphs there just for you to have to look at. Common graphs is what we're calling these. These are graphs that you should just know. Whenever you see the equation y equals x, you should know what that looks like. That is a straight line, goes through 0, 0, cuts the first and the third quadrants in half. 45-degree angle there. It goes through 1, 1, 2, 2, 3, 3, so forth. Y equals x. You also want to know y equals absolute value of x. Now here I'm calling it y, but remember it could also be f of x. Means the same thing. And that's the V shape. It still goes through 1, 1, 2, 2, 3, 3. V shape. Then here's the other three. Y equals x squared, the quadratic function. This is the basic shape, the basic graph for a quadratic function. And then we have the square root function. Has a starting point and then goes up to the right. And then the cubic function. This should have arrows on the ends. It doesn't here, but you can go ahead and draw those on. And that is the shape of the cube function. So again, make sure you learn these shapes. I'm going to go ahead and stop here, and if you wanted to practice point plotting on your homework, you can go ahead and practice that. In the next video, I will show you how to shift these basic graphs. We're going to learn how to shift them up and down and left and right.